So this problem is stating that Bryce leans on a ladder on a wall. So we can draw a wall, for example, right here. And he's leaning on a ladder on the wall, which is on an angle. And we know that the foot of the ladder is 6 feet from the wall. So if we draw the floor, for example, here, then we know that the ladder is 6 feet from the wall, which makes this 6 feet right there. And the ladder reaches a height of 15 feet on the wall, which can tell us that this is 15 feet because it's 15 feet up the wall. And we need to find the angle the ladder makes with the wall to the nearest tenth of a degree. So the angle that the ladder makes with the wall would be right here, and we can say that that is theta, because we do not yet know what that angle is, but we're trying to find it. And since we are trying to find this angle, and this is the reference angle, then we know that this is opposite, this is adjacent, and this is the hypotenuse. And because we are given that, then we can use 3 trig functions and to try and find this angle measurement. So the 3 trig functions are SO, CA, TOA as a shortcut, and this one being sin, this one being cosine, and this one being tangent. And this one is opposite over hypotenuse as shown there. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Since we are trying to find an angle measurement, and we are given the opposite and adjacent, and we can use the tan function. And because of that, we can use the tan function. And because tan is opposite over adjacent, we know that 6 over 15. And we can set that equal to tan of theta. And since we're trying to find the angle and get it by itself, we need to get theta by itself. So what we can do is multiply tan by tan negative 1. And that will get rid of tan and just make it theta equals tan negative 1 times 6/15. And when we multiply that together, we will get roughly theta equals 21.801. And because we need to find the angle the ladder makes with the wall to the nearest tenth of a degree, we can round that to theta equals 21.8 degrees. And that's your answer.